Happy snow day, everybody. I just wanted to do a couple videos for you guys to help you out while we're sitting at home trying to figure out the binomial model. The test has to be taken before spring break, so there is some stuff we have to learn. So this is going to be a few short notes on chapter 14, the binomial model. This is part 2. The first part was the expected value notes that we did in class. Okay, so what we're going to begin with is a little description of what the binomial model is. The binomial model is, the word bi, the prefix, means that there are two options. A probability of success and a probability of failure. It's up to us to determine which is success and which is failure of the given probabilities based on each different scenario that we're provided. Okay? So in the binomial model, there are a few requirements, okay? The binomial model. Okay? It consists of a series of independent, this is our keyword here, binomial trials. Okay? So independent means that for any of these values that we see, we can actually use the multiplication rule. So we need to keep that in mind. Okay? This signifies multiplication rule can be used. Okay? So it consists of a series of independent binomial trials. Each trial has a probability of success and a probability of failure. These are complements of one another, and they make up all the possible options. You either succeed or you fail. There's no middle ground in a binomial model, which is what we look for when we're trying to identify them from other problems within the class. Okay? So then, if we see that each trial has only two possible options, success and failure, then we can use the binomial probabilities to solve the problem. And we have two options. I usually go over the equation that we use to compute this by hand, but since we're not going to be doing that, I'm going to give you the options for the calculator. So we have two options, two calculator functions to use. Okay? The first is when we're dealing with exactly k successes. Okay? So k can be any number here, and when we say exactly k successes, we mean to say, imagine that we are, let's say, rolling a die 5 times. And we want to know the probability of getting exactly 2 ones. So that would be a 2 for k, and the number of trials we'd be doing are 5 because we're rolling the die 5 times. So the function in the calculator that we use is called a binomial PDF, and the entry pieces are n, p, k, where n is always the number of trials, p is the probability of success, and k is the number of successes. Okay? This NPK will be used again in our next formula as well. The next formula we use is for when we have k or fewer successes. Again, K can be any number. So same example, we're rolling this die 5 times and we want to know how many times or what the probability is that we would roll a 1 2 or fewer times. So we actually already use a similar formula to this when we wanted to do this with the normal model. In the normal model, we did normal CDF to figure out probabilities between two values. So for binomial, we're going to use the binomial CDF, or cumulative distribution function. And it has the same entries, n, comma, p, comma, k. Okay? So k, again, if it was 2, this model would say, the binomial CDF would say, well, we're going to take the PDF at 2, we're going to add it to the PDF at 1, and we're going to add that to the PDF at 0. So it takes all the values and adds them all together. Okay? So there's only a couple things that we haven't discussed about the binomial model. So I'm going to add them to these notes at the bottom here, since we know now what n, p, and k stand for. Okay? So the binomial model can be notated by binom n comma p, which means this is a binomial model with n trials and p as the probability of success. Because we only have the option of success or failure, we also have a letter to denote the probability of failure. So we use the probability of failure as the letter Q, and we do 1 minus P as the probability of failure. Okay, and there's only 2 other things I want to add to the notes. So I'm going to flip this over. I'm just going to add 2 more notes on the back of this sheet. That is the mean and standard deviation for the binomial model. The mean is equal to n times p. So whatever the number of trials are times the probability of success. But the standard deviation is equal to the square root of n times p times q. So we do have to calculate the probability of failure in order to find the standard deviation in any example that we're working on. Okay, those are my quick notes on the binomial model, and now I'm going to shoot a couple videos doing a few examples.